Okay. Okay. So, hey everyone. Thanks so much for being here. I'm Firoz, and today I'll be walking you through a super thought-provoking benchmark study from OpenAI, and it's called PaperBench, which explores a surprisingly deep question, and that is, can AI actually replicate cutting-edge AI research independently like real researchers? Uh, well, it sounds ambiguous, and honestly, it is. So, yeah, let's get into it. All right. Before we talk about PaperBench itself, let's set the context. AI is advancing fast, like seriously fast, but along with the progress comes a big question. What happens when AI starts acting on its own? Are we prepared for that? Because here's the thing. AI isn't just automating spreadsheets anymore. It's transforming medicine, education, science, and even decision making. But that power comes with risk. Cybersecurity threats, misinformation, and maybe the scariest one is unintended autonomy. Uh, this slide sets that tension perfectly. AI has a huge potential, but we can't ignore the responsibility that comes with it. So, how do we move fast and stay safe? That's where the OpenAI's preparedness framework comes in. So let me walk into that. Uh, the preparedness framework is OpenAI's way of turning their mission, that is safe and beneficial AI, into concrete and measurable action. Uh, and yeah, there's a great line in their preparedness framework paper that says the whole thesis behind this framework is to build a robust approach to AI catastrophic risk. Safety requires it requires proactive science-based determinations of when and how it is safe to proceed with development and deployment. So not just hoping that things go well, they are actually building tools and systems that helps decide when it's safe to move forward. And this framework ensures that every powerful model goes through the safety check before it is unleashed. It looks at risk, uh, it builds safeguards, and it tracks whether safety efforts are actually working. And one of the most crucial risk areas they focus on, it is model autonomy. That is, can AI act independently, and is that something we are ready to handle? So yeah, that's where the paper bench comes in. Uh, Okay, let me take a moment to quickly walk you through how the full preparedness framework works, because it is more than just a philosophy, and they have built an actual system. So yeah, here's how it breaks down. First, OpenAI defines its risk categories, and they are cybersecurity, CRBN threats, that's chemical, radiological, biological, and nuclear threats, and then persuasion, and yeah, of course, the model autonomy. Then they use scorecards to evaluate models before and after the mitigation, and they enforce safety baselines. Uh, they are basically the thresholds that a model must meet before the release. And there's a full preparedness team doing hands-on evaluations, and even the safety advisory group giving leadership input on high stakes decisions. And well, all of this can be seen through the preparedness framework paper that I'm talking about. They have mentioned a lot of it on there. So yeah. Now we come to the main topic. Now let's officially meet PaperBench. So the idea here is really bold. Can we test an AI's research autonomy by taking it to replicate real-world research papers, and that is without help? In other words, just to make it simple, give AI a research paper and give it no implementation or any pre-written code, and ask the AI if it can figure out how to reproduce the results on its own. And that's what PaperBench is all about. It's OpenAI's way of measuring how independent these models are becoming when it comes to the real science. So yeah, let's break it down. PaperBench consists of 20 ICML papers, and ICML stands for International Conference on Machine Learning. And spanning 12 diverse research topics like deep reinforcement learning, robustness, and even probabilistic methods. So the agents, AI agents are given structured markdown versions of each paper, given the clarifications from the original authors, and they are told, like, here's a paper, and reproduce it from the sketch. So yeah. Yeah, and the most cool thing about this whole PaperBench thing and the preparedness framework is all of the codes are open source, and you guys can go through the preparedness project. Uh, yeah, the preparedness project framework, the repository on the GitHub, and you guys can just find the codes and every documentation over there. So in the repo, you will find paper files, the rubrics, which we will be talking about later on, the two agents, basic agents and iterative agents, how they are handled, and also how we execute inside the Dockerized Ubuntu environment and everything. So yeah, let's first try to understand the process. Yeah, okay, so here is the flow diagram. And this diagram represents all uh, the entire PaperBench working process. So yeah, I will try to break it down. I'll try to break it down. So yeah. So first, let's talk about what the agent does. So it reads the paper description and the markdown file. The researchers they give, or the authors, the original ICML authors, they give the paper description, in the form of markdown, including all the findings and requirements that are needed to replicate the paper's main contributions. And then it generates a code repo from scratch. The agent, it generates a code repo from scratch, and it writes the reproduce.sh, the bash script. That is the single point of execution that we'll be talking about in the next process. And it writes a README file, another README, another Markdown file that describes all the reproduction steps. So yeah, and when all of this thing is done, the whole thing gets shipped to a clean Linux virtual machine, the Ubuntu 24.04, the Dockerized version. So yeah, which I was talking about this later, this before. And here is the breakdown of how much we have gone deep into. So yeah, And okay, first, here's the important part. So why we are using the fresh OS or the new, so why you are using the clean Linux virtual machine? Uh, it is because it prevents any chance of agent hard coding answers or sneaking in shortcuts. It's like giving the agent uh, a clean lab table, and no any cheat sheets are provided. So yeah, basically everything is done by agent itself, giving, and this setup makes the result much more trustworthy. And yeah, all the results that are created are saved in a table or figure format, like the any sort of findings or the graphs that we get, they are saved in table, CSV files and PNGs. Yeah, well, we have it over here. And okay, so now comes the tough part, and that is grading. We can't just eyeball whether an AI did well. So we need a structure. So OpenAI worked with original authors, the ICML authors of each paper to build a massive hierarchical rubrics. And those are just the tree-like structure, and they have the binary checkpoints. Yeah, this is the rubric, and uh, and they have 8,316 test criteria, and each leaf node specifies a single criterion with a binary score of whether it is true or false, or whether it is 0 or 1. And the structure, as I said earlier, it is a hierarchical tree structure, and the parent nodes cover three key criteria, and those leaf nodes have three main criteria, and they are uh, based on whether the result is matched or not, whether the code or the script ran or not, or it got executed or not, and the code development phase. So in the code implementation, code development part, we'll just see if the agent is heading towards the right direction or not, even if the results didn't match. So yeah. Uh, well, here is a diagram from the paper describing the rubric structure. In case you didn't get it, I have created a small animation type thing just to make you guys understand what's going on here. Uh, I'll just be covering a smaller part, and then we can just get what's going on. So yeah, what happens here is, 0, 1, 1, I'm taking this part to uh, talk about. The last leaf nodes we are talking about. So what happens here is, yeah, first, all of the, yeah, first, okay, let's start from the scratch. What happens here is these two get multiplied, every weight and the values get multiplied, and all of these weights, they are added in order to get the parent node value. And this way we can basically get how much the scores of how this is going on. Like the scores, the rubric score is basically uh, it is the weighted average. So yeah, um, okay. So grading that many checkpoints manually would take forever. So what they did is the OpenAI team, they built a simple judge, and it is a LLM-based grader that uses O3 Mini and it reads the rubric, the code, the results, and evaluates the submission. And to keep it honest, they built a human-graded dataset called Judge-Eval. Basically, humans grade a sample set so the LLM judge can be validated and tuned. It's basically it's basically a dataset, and yeah. And regarding the result, this LLM judge, simple judge, and Judge Eval, the Judge Eval gave simple judge accuracy of it was 84%, with massive time savings, and honestly, a very smart use of AI to judge AI. And one thing that struck me while reading this paper was how hard it is actually to set up a benchmark like this. Uh, you can't just throw a paper at the AI. You need author input, detailed rubrics, clarifications, and even then, it's a ton of setup effort. Just preparing 20 papers was a huge thing to do. So while it isn't just the most scalable method right now, it's honestly the best we have got if we want real, rigorous evaluation of AI autonomy. And yeah, so and yeah, I forgot to talk about the cost. So yeah, on the full PaperBench submission, uh, it was around $66 per submission. It is written in the paper. And the lighter code dev version, which just evaluates the code, it took $10 per submission. It might sound a bit expensive, but if we were to hire an expert group for this, it would take longer, and even they would charge a significant amount of money. So we can consider it as still way cheaper than hiring human experts for manual grading. Now, they even experimented with trying to benchmark the AI against the human researcher. So how did the AI do? Cloud's 3.5 Sonnet scored around 21%. Iterative agents, and yeah, that was the basic agent. And on the iterative agent, helped the O1 research. Yeah, the O1 iterates 26%, and meanwhile, the human replicated for 41% of the papers in 48 hours. And interestingly, in the code dev variant, which only checks code quality, the O1 model hit 43.4%. And that tells us something like that is AI can write a decent code. But when it comes to end-to-end research, humans are still ahead. And yeah, so here is the tables from the paper itself. And yeah, we can see in the basic agent, Cloud 3.5 Sonnet hit 21%. And on the iterative, yeah, interesting thing over here is while we were trying to go in iterative agent, the Cloud 3.5 Sonnet scores, it decreased, while the O1 scores like O3 Mini or even O1 High, their score increased significantly. And with extended 36-hour limit, the O1 highs score was like 26%. So yeah, that was kind of interesting part. Okay, so here we have a graph. And this is another fascinating insight from the paper. If you look at the time graph, in the first hour, AI actually performs better than humans. But as the time goes on, AI plateaus, while humans keep climbing. Why? It is because humans strategize, they debug, they learn as they go. But when it comes to AI, it just ran out of steam. And yeah, so yeah, basically the humans within 48 hours they reach the top, while the blue line here it just tries to show the agent structure, agent progress, and yeah, it is kind of stagnating. But humans are the graph regard of the humans, it's increasing. Uh, so yeah. Now we are at the end. So, what does all of this mean? Uh, well, AI is not taking over research anytime soon, at least not all of it. Yeah, it's fast at writing code, and yes, it can look impressive in the early stages. But when it comes to long-term problem solving, interpretation, debugging, and strategy, humans still win. And they win by a fair margin. So for now, we are safe. The machines are helpful, but they are not replacing the experts or the PhDs anytime soon. And personally, this paper was joy to read. It was thoughtful, rigorous, and gave a deeper appreciation for how complex and nuanced AI safety research really is. So yeah, we even have a SWOT analysis. We can see the strength of this agent is like, or the entire process is like, okay, so we have this, the agent does, it had 84% accuracy. So yeah, efficient automated grading. And weakness is that AI agent was basically it had lower replication score than humans. And observation, we can see the, yeah, we could we could improve strategic reasoning capabilities of the AI on later on. And yeah, there are time constraints and safety concerns regarding this project. Like even to build a simple rubric, uh, the researchers and the ICML paper writers, they spend a significant amount of time. So yeah, this paper is the experiment done. It is not optimal, but there is no other optimal way to do other than that. So yeah, that wraps up my presentation. Thank you all for listening. I hope PaperBench gave you something new to think about. And yeah, that was it for my paper reading session. Thank you.